Okay. And we are back in Discord as well. So technical Q&A is where people should be sending stuff in. So, okay. So I will be moving on to VS Code. I think some of you have started using VS Code already. I'll start typing stuff in VS Code. I will have GitHub Copilot on. So GitHub Copilot is GitHub Copilot is the tool that we're going to be using to basically do auto-completion. It's extremely powerful. So it can, this is just the syllabus. So it could do anything, including write something like the syllabus, right? So you could just say, like, write a description, like with ChatGPT for ESC190 computer algorithms or something. And if you wait a little bit, it'll start suggesting stuff. Right now, for some reason, it doesn't want to. I think the internet is working. Okay, so it is not super reliable. Sometimes it will just not complete it. I think it might be that I'm not saving it correctly. Just one sec. So if I save it like this. Well, sometimes it just refuses. So in that case, we'll just switch to the actual slides about the course anyways. Say again? I didn't. I mean, it was on in the first place. Oh. Wait, why was it? Oh, it just doesn't want to do it for MD, I think. So over here, yeah. So this does that work? It just was not liking the file type. So this is LaTeX, so that's like a way of creating document, and this is how I made the ESC190 syllabus. And here, indeed, it's suggesting, for example, code for, well, this is like not very good actually, but it's suggesting like stuff that I could write in the document. So here is the actual list of topics that you have in the document. So we'll start with problem solving recursion. We'll do a little bit of a review of complexity analysis, move into C. So here, and it's sometimes convenient. So like maybe I want to add something and I wanted to suggest something. It doesn't want to suggest anything. That would be annoying. Yeah, so here it's suggesting sorting algorithms. It's a terrible idea. We've already done that. But with coding, you'll see it's also very useful. So part of the reason that we started with Paizo is that in Paizo, some of the things that I really want to do, which is go through the code line by line and debug line by line and run code as I'm debugging. In Paizo, it's very intuitive. In VS Code, you have to actually set it up so that it kind of works the same way as it does in Paizo. I'll have instructions for how to do that later on. For now, today is just going to be demonstration. So please install GitHub Copilot. So that's on the next slide. Anyway, coming back to the format, same format as ESC180. So we have two projects. So basically, there's scheduling constraints that don't really allow 3 projects. And this year, the project is going to be due after reading week, project 1. So before reading week, there's going to be 2 online labs similar to what we had in ESC180, just to make sure that people are not behind. So what are we learning in ESC180, 190, at least how I think about it? So we're learning how computers work, right? So how computers store information in memory. and stuff like that is part of how computers work. And part of the reason we're learning that is just because maybe you want to make a new computer. And part of the reason is that actually, even if you're just writing Python, it's still sometimes useful to be able to, right? It's still sometimes useful to be able to know how the computer works inside, just in order, for example, to predict, is the list going to change or not when I try to change it inside the function. So the other focus is how to solve problems using computers. And part of it is how to do it efficiently, how to approach the problem-solving process in general. Part of it is here are like specific techniques that allow you to do problem solving, like, for example, loops, right? Like, for example, nested loops. And then we go more into depth with those particular techniques that happen to work for a large number of problems. And the goal is twofold. So one is, well, I want you to actually learn how to solve those specific problems. But another goal is to say, well, somebody figured out at some point how to do nested loops, and hopefully you'll get the same kind of idea of how the general problem-solving process works. Maybe one of you will figure out something that's as prominent as nested loops are. Kind of more to the nitty-gritty. So ESC190 is like basically a mix of Python and C, and that's because problem-solving is easy in Python, but you also need to learn C. Well, one, there's no point in trying to sell it. For one, you're going to do it one way or the other. For two, it's easier to sell why you need to know C after you know C than before. But basically, the argument is, in order to know how computers work, you need to know C. Also, knowing C and knowing how computers work sometimes allows you to write code that's much more efficient. In terms of the curriculum, well, like you do C in first year ENGSI, and then in second year, you get kind of to a much lower level of programming where you actually kind of work directly with the hardware. C is kind of in between working in Python and working directly with the hardware. Again, this would make much more sense if you already knew what C was about, which you will in about a month, I would say. So we'll start on Thursday, but you'll know in about a month. Okay. And yeah, so moving to VS Code, so GitHub Copilot, which I realize wasn't impressive up to now, but it really is very useful. Please install it and try it. So GitHub Copilot is free for educational use. So if you just Google like GitHub Copilot education, there is a process that you go through in order to get it for free. Otherwise, it's like, I think I pay, I don't know, like $100 a year or something. So yeah. So, okay. So that's 190. The syllabus was sent out before. Basically, everything is the same as 180. I have not gotten my course, so I don't know if you guys have gotten the 180 marks, probably not either, but I also haven't gotten my evaluations. So like if there is like, if, for example, everyone really hate quizzes, maybe we won't have quizzes, but for now, everything stays the same. I have not heard about people really hating quizzes yet. Everything else is non-negotiable. So, okay. And I guess now that the syllabus is posted, the only way to change it is to have a vote on it. So, okay, all right. So I want to come back and do problem solving for now in Python. So if you're working in VS Code, you need to save the file. This is like one of the ways in which things are a little bit more annoying, is you need to save the file in order to let VS Code know that you're actually writing a Python file. So here I saved it as a.py. So in order to make things as close as possible to Paizo, which I think is good because I think Paizo has a really good setup, I'll start IPython3 in the terminal. So what I did is I started the terminal window if there wasn't one, and I said new terminal. Let me make the font a little bit larger. And now, so that you need to set up a little bit, but you can do the same kind of things as in Paizo. So here I can highlight a equals 5, for example, and just run it like this. So same. And here, again, I can say a equals 5. You'll see that there's some advantages to using this setup already. So for example, here it kind of suggests this auto-completion of a equals 5. Not a super useful auto-completion in this case, but it does auto-completions better, and it does it in the shell as well. I can run the whole thing using the play button. So in this case, I ran it and nothing happened. That would be because I did not print anything. So if I print, that would be like this. So, okay. So what I want to talk about now is deep copy again. So to remind you, if you have something like this, and this is L, so you can do a shallow copy of L, and that would be something like this. So this is just using slicing, or this would be the same as L2 equals L.copy. So shallow copy means that L and L2 are separate lists, but the elements of L and L2 are aliases, right? So L and L2 are separate lists, so that means that changing L0 is not the same as changing L2 at 0, right? So you say, I want L at 0 to be something new instead of this, it will be, that's fine. On the other hand, changing the contents of L0 is the same as changing the contents of, right? And so that means that L at 0 equals 3 changes L2 at 0 to 3 as well. Is that making sense? So why is that? Well, because basically we have this list L and it has 2 elements. So one of the elements is, in fact, it has 1 element. We add one more. So it has 2 elements. So one of the elements is this guy. And then L2 is a copy. So the copy means L and L2 are separate lists, but it's just that there's only one copy of the inner list. So when you're changing the contents of the highlighted list there, what's going to happen is, well, those contents are going to change, and you can access those contents at 0, or so you change one, that means you change the other. So you can try and that's what we so just to remind people, so if you have something like this, you can say L2 is a copy of L1, a copy of L1. So what you're doing, first element of this list is going to be not true. So L1 is L1 0 complement. And then a copy of this that if you copy simple lists, can I create deep copies of more complicated lists? And the answer is kind of yes, right? So look at this. If I could make a deep copy of this guy and then make a deep copy of this guy, then I can basically use this kind of strategy, right? So if only I can just have a function that I can use as a helper function that would make a deep copy of the first element and then a deep copy of the second element, I'd be done, right? So that would be the recipe, right? So to create a deep copy of the list L, make a new list, deep copy of L at 0 and deep copy of L at 1, and so on. Right? And to the extent that you can make a deep copy of the first element and then a deep copy of the second element, well, you'd be done. You just create a list that combines all of those. So that's what we're going to do. And you'll notice, so this is like a common story. So Copilot basically knows what I'm about to write anyway. I'm not gonna just say, well, like we're done with the lecture. So what are we gonna do? So we're gonna say, okay, so assume that L is a list. Then what I want to do is I want to say for E and L. And now I basically need to say, okay, like if E is a list, then I want to make a deep copy. If E is not a list, then I'm done and I can just append it. Right. So I'll say the result initially is nothing. And if E is a list, so you can use type E. If you remember, we did it very briefly in 180. So if you do like type whatever 3 high, that would be a list. This would be a string, stuff like that. So if this is a list, we'll say make a deep copy of this element and append that to result. If it's not a list, we're done. We'll just append. So if it's, for example, an integer, we'll just stick it into result. And here, I'll just return result. Okay. So the only thing here is just to be nice about it, we need a base case. So what would be the base case? Well, the base case would be if E is not the list, or if L is not the list, rather, then the deep copy is just the thing itself. So we'll just return L. So at this point, I'll write the doc string. So return deep copy of L, which is either a list or in this case, I'll say or an int. And here, the deep copy of the integer, if L is actually an integer, the deep copy is just the thing itself. Otherwise, we create a fresh list and we go element by element in L and we say, just make a deep copy of that element in L and append that deep copy to the result. So how would it work with this guy here, for example? Where is it? Sorry. Yeah, so how would it work with this guy here? Well, what we're doing is we're saying, make a deep copy of this guy and append it to result. And then make a deep copy, well, don't even make a deep copy of this guy, just append it to the result because we check whether it's a list or not. Yeah.
Do you ever reach the base case like this?
You're right. If I start with a list, it wouldn't, but if I call it with an integer, then yeah. So you're right. Technically, I could just say, well, I'll just make sure that I only ever call it with lists, in which case there wouldn't be an issue. Right? And then why does it work? Well, recursion. Like the reason the entire thing is a deep copy is that you first make a deep copy of this, and then you make a deep copy of this. How does it work here? Well, again, it goes element by element, and it says, make me a deep copy of this, and then make me a deep copy of this, stick that in a fresh list. Okay. So that's it. So really simple at the end, right? But you have to have the right idea, which is just how do you make a deep copy? Well, just create a fresh list in this case, go element by element, and make a deep copy of every element, append it to the fresh list. Questions? All right. So I want to do another example where recursion turns out to be useful. And again, kind of to remind people, because it's been a month, and although like that's probably not like super difficult. So we had this idea of enumerating strings over an alphabet, right? So if you have an alphabet like this, you can say whatever. So here, if I don't save it, it's not going to autocomplete for me. And this is something that we've done in ESC190 as well, so I don't feel bad about just using the autocomplete. Obviously, it would be difficult for you to copy. Not autocomplete. Oh, okay, there you are. So something like this would give me all the strings of length 4 over the alphabet, right? Right, so here, what's going on? Well, we're just saying letter 1, it goes A, B, C, D, E, F, G. So we try every possible letter 1, and when letter 1 is A, we try every possible completion, right? So here, what we're saying is try every possible letter 2, every possible letter 3, every possible letter 4. So this is kind of from 180. So is this good with everyone? Cool. All right. So let's say that what I want to do is so want to list all the strings of length k over the alphabet. And we had a trick for that, right? So we like made code that itself wrote Python code that created this. But it was kind of fun, but also kind of silly. Here's what you can do. Again, just think recursively. If I can do it for strings of length k minus 1, how could I use that in order to get me all the strings of length k? Right? And the answer is, well, it's kind of this, right? So I can say for letter 1 in alphabet, right? Like that's the idea. If I can do it for strings of length k minus 1, I can also do it for strings of length k by just saying for letter 1 in alphabet, and then do letter 1 plus anything that's of length k minus 1. So that's, again, the pattern of the thing we want to do is list all the strings, and we kind of know how, if we kind of know how to do it for smaller strings, then you can build it up to larger strings. So, okay, let's write that. Well, so we'll start, okay, so we're building up this list of everything. And I'm just going to say, okay, so for letter and alphabet, and now I just want to add this kind of thing. So letter and then the first string, and then letter and then the other string, and so on. So this would be like number 1, number 2, number 3, and so on. So I can say for all k minus 1 strings, well, I'll just get me a list of all the strings that are of length k minus 1 that use the alphabet. That's using itself as the helper function. Does that make sense? Again, it shouldn't necessarily completely make sense in the sense that you're kind of trusting this process. The process is I'll call the function as its own helper for a smaller k, and assuming that works for the smaller k, I'm building up the solution for the larger k. Okay. In fact, I can do it. Okay. And now I'll just go through all the strings. So string 1, string 2, and so on. And I'll append the letter plus this string. So each of those strings is of length k minus 1, right? And then you're saying append letter plus string. So this thing is going to be of length k. And how do we know that we'll get all of them? Well, we got all the possible strings of length k minus 1. And then we just said like A plus every possible one, and then B plus every possible one, and then C plus every possible one. Well, that's going to get you everything. Does that make sense? So maybe that's kind of belaboring the point a little bit, but how do you get all the words in the dictionary? Well, you get all the words that start with A, and then all the ones that start with B, all the ones that start with C, all the ones that start with Z. Well, by the end, you'll have everything. Okay. So this is like this. You'll note that here we didn't really need to call this multiple times because it's going to return the same thing every time. So we might as well move it over here. And at the end, we'll just return the result. So the only thing here is what's the base case? Well, the really simple situation is if you want all the strings of length 0 that are using the letters of the alphabet, strings of length 0 are just empty. So I could just say, if k is 0, we'll return the empty string. One. Make sense? So thinking about it from the bottom up, why does it work? Well, it works because if you can get the rest of the string by kind of just getting all the strings that are of length k-1, and then you prepend every possible letter, well, that gets you all the strings of length k. Here, it's also worth thinking about it from the bottom up, I think. So what happens when you call all strings with 0? Well, that just returns a list with nothing in it. So then what does it mean about all strings 1? Well, it should do this. So this is all the strings over this alphabet that are of length 1. Why would it work like that? Well, because all k1 strings for k equals 1, that is going to be, imagine that k equals 1. That would be just a list that contains the empty string. And then here you're saying for every possible letter, append letter plus the empty string. So you'll append A plus the empty string, and then B plus the empty string, and then C plus the empty string. And what you'll end up with is res that has A and B and C and D as separate strings, right? So you'll end up with this. So imagine that you want all strings 2. So Copilot still knows how to do this amazingly. So you can get, this is like all of those. So how would you get those? Well, if k is equal to, so if k is equal to 2, then all strings of length k-1 is going to be, right? So then we're saying for a letter in the alphabet, so letter is going to be A at first. And when letter is A, what's going to be appended? Well, it's going to be A, and then A plus this A, and then A plus B, and then A plus C, A plus D, A plus E, A plus F. And then letter is going to be B. So it's going to be B plus A, B plus B, B plus C, and so on. So that will get you this kind of. At this point, it might be easier to start thinking about it. Well, if it's 5, well, what's going to happen? Well, if k is equal to 5, what's going to happen is we're going to say A and then stick all the possible strings of length 4 to the right of it. And then B, all the possible strings of length 4 to the right of it, and so on. So I think on one of the past exams, the complexity of this was one of the questions. So like, what's the complexity of this kind of thing? Maybe it wasn't exactly this kind of thing, something like that. So what happens? Well, let's say that you call all strings with the parameter k, trying to keep it all on the same screen. Yeah, unfortunately, Copilot is not great at drawing trees yet. So that's like this. So what's going to happen? Well, k is going to call k minus 1. And then k minus 1 is going to call k minus 2 and so on, right? So all of that just happens to once. It's going to be here it's going to be more, right? So here what's happening is bringing so alpha loop is going to be less than the alpha. So the outer loop is 3 times as there are strings that are of length k minus 1. Right? And then this is going to repeat again n times the number of strings of length k minus 2. Right? And this is n times the number of strings of length k minus 3, and so on. Right? So what's the number of strings over the alphabet that are of k minus 1? Back to how we generated lists with loops, right? So how many times does this guy repeat? Well, n to the 4, right? N to the 4 because this repeats n times, and this repeats n times, and this repeats n times, and this repeats n times. But also repeats as many times as there are 4 letter strings over the alphabet. Right? It prints every one. It repeats once when it prints it once. And it repeats n to the 4 times. Why? Because this repeats n times, and then you're saying repeat this n times, and this repeats n times, this repeats n times, this repeats n times. So going from the top to the bottom, it's n to the 4. You can also think about it as like, this is n times, repeat n times itself. So this is n squared. So repeat n squared n times. So this is n cubed. Repeat that n times. So this is n to the 4. And this is the process for making all the strings of length 4. So how many strings of length 4 are there? N to the 4. How many strings of length k minus 1 are there? N to the k minus 1. So that's n to the k. And then this is n to the k minus 1. and so on. So the total number so that's n to the k plus n to the k minus 1, and so on. And that's, again, the geometric series. So n to the k plus 1. So Copilot really wants to say O of n to the k. Whether that's correct or not depends on whether you consider k to be a constant or not. So if k is a constant, then even then it's not really, because like n to the k plus so if k is a constant, yeah, like you divide by n, so it's approximately n to the k. If k is not a constant, you just write it like this. Yeah.
Why would K not be constant if it's specified the function, and the function is called and not changing?
Well, I mean, like everything's specified once the function is called. Alphabet is also specified. So it's more a question of like, are you interested in knowing if alphabet becomes very large, what's going to happen? Or are you more also interested in knowing, like, if I try to call this function with a very large k, how is the runtime going to change? And probably you're kind of interested in both, right?
Well, if you were to be asked this something on an exam, should we just leave it as the
I would. Now, like those are like pretty close either way, but yeah. All right. Questions about this? All right. So please install Visual Studio Code. So labs don't start until next week, but there's gonna be a tutorial on using Visual Studio Code for Python. So next week you can. Next week, like there's going to be a little bit of an exercise on using Visual Studio Code in Python, and we're starting C on Thursday. All right. Good seeing everyone. I'll see you Thursday. Bye. So did you get the grades? No, right? No. Okay. So I know like you got 103, right? Or what do you get? What do you get? Okay. Oh, so just looking at that. Oh, 6. Okay.